Hello and welcome to the IQ Technical webinar about thermal breaks in metal framed windows and doors. First of all, it's important to understand why thermal breaks are important in metal framing. This graphic here shows the path of heat loss that you'll experience through a non-thermally broken frame with a non-insulating piece of glass. This type of frame is a very traditional framing section, and it was designed back when thermal insulation in buildings wasn't as important as it is today. So if you use a non-thermally broken frame, you will get heat loss through the frame, and then when you pair it with a non-insulating glass unit, like the single glazing shown here, you'll also get heat loss through the glass. This is a non-insulated glass installation. Some traditional metal frames will allow for the use of double glazing within the profile. This then will reduce the heat loss through the glass, but it doesn't eliminate the heat loss that you get through the non-thermally broken frame, and you can see that here. In order to create a truly insulating window or door, you must use an insulated glass unit, like a double or a triple glazed unit, paired with a fully thermally broken frame. This profile shown here is the thermally broken steel system from Mondrian, the CWS 50 Slim, which has got a full thermal break within the profile. And you can see that using this with a double glazed unit creates a fully insulated glass installation. Thermal breaks will have a real effect on the thermal performance and overall UW value of your glass installation. The overall UW value for a window or door is made up of various parts. It includes the thermal performance of the frame, that's the UF value, the thermal performance of the glass, that's the UG value, and the thermal performance of the spacer bar, and that's the psi value. All of these values come together to create the weighted U value for the window or door. This is called the UW value. Building regulations state the minimum UW value you need for your project, and you can see those values written here. By understanding how a UW value is calculated, it's easy to see then that if the thermal performance of the frame is low, because you've used a non-thermally broken profile, it will affect the overall thermal performance of the installation. You should always make sure that the U value that you're quoted by the glazier or supplier is the actual UW value for the installation. Because sometimes if a system is non-thermally broken or not very well insulating, some more disreputable sources may quote the UG value as the U value. This can be obviously misleading for specifiers who want to know what the overall thermal performance is, so it's important to get clarification as to what values you are being told. It isn't just the technical thermal aspects of a building that will be affected by using non-thermally broken profiles. If non-thermally broken systems are used between inside and outside, then the internal piece of frame in that system will be very cold. This is a prime surface for condensation to build up internally. That can then damage internal building finishes or soft furnishings like carpets or curtains. If it's very cold outside, you could even experience a frost build-up on the inside of a window or door. This is why it's so important to use a true thermally broken system to separate two different climates. So let's have a look at some real systems and the effect that their thermal breaks have on their thermal performance. This first system shown here is an aluminium system from the Seeger range, aptly named the Seeger Slim window. It has an overall depth of 70 millimeters and a vent plus framing profile of 65 millimeters. This is very slim for an aluminium system. You can see from the U value breakdown how the UG value and the UF value come together to offer a typical UW value of approximately 1.2 watts per meter squared Kelvin. An alternative option in aluminium is the Seeger steel look system called Seeger Legacy. This is useful for projects looking to create a more industrial steel look, but with an aluminium frame. The sightlines here achieved are 58mm across both the fixed frame and the vent frame, and this is in keeping with the visual design of a more traditional steel system. The reduced depth of 47mm also makes it a little bit more suitable for older buildings or replacement glazing. Again, you can see when you look at the UW value breakdown that the shallower thermal break used in the legacy system, highlighted in red, doesn't offer as much thermal insulation in the frame as the one shown previously, and this results in a lower UF value and then results in a lower UW value. You're normally looking at a UW of 1.5 watts per meter squared Kelvin for the Sega legacy system like shown here. Now we have a look at some steel systems. The profile shown here is the CWS 50 Slim system from the Mondrian range. This has a thermal break, it's highlighted in red, and you can expect to achieve a UW value of approximately 1.5 watts per meter squared Kelvin for a very typical installation. For better thermal insulation in a steel frame, the Mondrian CWS 65 Slim system uses a slightly different thermal break material which reduces the UF value and therefore gives you a slightly better overall thermal performance. You would normally be looking at UW values from about 1.4 watts per meter squared Kelvin with this type of thermally broken steel system. The beauty of steel systems is that you can get a very narrow sightline, but the inclusion of a thermal break into a steel window system doesn't have to mean a huge increase in the frame sizing. Here you can see a very traditional steel section, the CWA 20 system from Mondrian, compared to a fully thermally broken section, which is the CWS 50 Slim section from Mondrian. And you can see that the increase in profile size is very minimal, but the improvement that you get in the overall thermal performance is very significant. This is a visual comparison of the two systems. On the left you can see the thermally broken steel solution using Mondrian profiles in a Belgium door configuration, and on the right is a very similar door configuration using a non-thermally broken solution. You can see that the visual design is almost identical. Another useful comparison is a thermally broken steel system versus a thermally broken aluminium system. A steel look aluminium system, like the one shown here from Sega Legacy, can be a really good alternative to thermally broken steel on some projects. This could be where the budget doesn't allow for the use of steel systems, or if you're in a more harsh environment and the corrosion of an architectural metal finish could be a worry, for example in a swimming pool or in a marine environment. Here you can see the Sega Legacy system, the steel look system from Sega, compared with the Mondrian CWS 50 Slim system, which is a thermally broken steel solution. You can see that the sightline difference between these two steel and aluminium systems is very small. The Sega Steel Look aluminium option is only 0.5mm bigger in sightline than the alternative steel solution. Again, let's have a look at a visual comparison of the two systems, and you can see that there isn't really a huge visual difference between the thermally broken steel and the thermally broken aluminium system. The main visual differences between an aluminium and a steel system tend to be at the corner joints, which you can only see in very close-up environments. In steel systems, these corner joints are welded and smooth. In aluminium systems, these joints are mitered and cleated. This then leaves a very faint visible joint at the corners, which you can see if you look at the system very close up. Other than that, the design is very similar from both systems. This can then allow you to achieve the more industrial artisan design wanted for the project, even with a reduced budget. So that is the end of this webinar. We hope that you found it useful and that it has helped you to gain an understanding as to why thermal breaks are so important in metal framing, and also has given you some ideas of the options that are available to you on your project. On this screen here you can see some of the resources that are available to you if you wanted some more information. All of our systems mentioned in the webinar are available from IQ Glass UK, and you can see our website address on the screen here. The aluminium systems mentioned were from the Sega range. Their website is on the screen. And the steel systems mentioned were from the Mondrian range. Again, their website address is shown on the screen for you. If you do want to see any of these systems in person, or you want to have a one-to-one technical meeting with a consultant, the best place to do that is at our showroom at Sky House. We're based in Amersham. All of these systems are available to view here, as well as all of our other products. It's a very comprehensive showroom. If you'd like to arrange an appointment, just give us a call. The telephone number is on the screen, or visit our website and go to the Contact Us page. There's a showroom request appointment form that you can fill in there. Again, we hope you found this useful. If you do have any questions or comments or feedback about this webinar, do feel free to leave them in the comments below. Or if you have any suggestions for further webinars, let us know and we'll try to get these arranged.